This is Chemistry Made Simple YouTube channel. I take this opportunity to welcome you to another learning segment. Today, we look at two other basic concepts used in organic chemistry. And these are, number one, functional group. Number two, homologous series. First things first, welcome to functional group. What is the meaning of the words functional group? A simple definition of functional group is that a functional group is an atom or a group of atoms, a type of chemical bond that is present in an organic compound and is responsible for the specific chemical properties of a compound belonging to a specific homologous series. Displayed besides here are some of the common functional groups and their names that you may encounter in your quest to study and understand organic chemistry. Number one is the functional group carbon to carbon double bond, and this predominantly belongs to the homologous series alkenes. Number two is the functional group carbon to carbon triple bond, which also belongs to the homologous series alkynes. Number three is the functional group hydroxyl group or OH group, and this belongs to the homologous series alcohols. Number four is the functional group carbonyl group, which belongs to two homologous series, and these are ketones and aldehydes. And number five is the amino group, which belongs to the homologous series amines. And for today, the last functional group that we look at is the carboxylic group, which predominantly also belongs to the homologous series carboxylic acids. Mind you, there are so many other functional groups in organic chemistry, but for explanatory purposes, I have chosen only the few above. With this being mentioned, I therefore take you to the next basic concept for today, and that is homologous series. Ladies and gentlemen, welcome to homologous series. What is the meaning of the words homologous series as applied to organic chemistry? So, a simple definition or explanation of what it means by a homologous series is that a homologous series is a family of organic compounds in which every member differs from the next member by a methylene group. So if you are having compounds such that one compound differs from the next compound and the next compound differs from the next compound by a methylene group, then the three compounds are said to belong to the same homologous series. Examples of homologous series that you will encounter in your quest or study of organic chemistry include the following. Number one, alkanes. Number two, alkenes. Number three, alkynes. Number four, alcohols. Number six, carbonyl compounds. Number seven, carboxylic acids. And for today, the last homologous series that we give as an example is a homologous series of amines. But mind you, as I have said previously, is that there are also several other homologous series that you will encounter. So the examples I have mentioned are just for purposes of clarity. In addition to this, all homologous series must obey the following 4 general properties, or call them characteristics. Characteristic number 1 is that members of a given homologous series must conform to a known similar general formula. Now, with reference to alkanes, the general formulas for alkanes as a homologous series are 2. The first one displayed besides here, whereby n is a natural number. That means n takes on the integral values 1, 2, 3, 4, and so on, is strictly the general formula for aliphatic alkanes. And the second general formula displayed also besides here, whereby n is still a natural number greater than 2, implying that n takes on the integral values 3, 4, 5, 6, and so on, is the general formula for cyclic alkanes. Property number 2 is that members of a given homologous series can all be prepared by using the same chemical methods. For example, still with reference to alkanes, is that alkanes can generally be prepared from the catalytic reduction or hydrogenation of alkenes. A case in reference is the preparation of ethane by the hydrogenation of ethene in the presence of nickel catalyst at elevated temperature, as represented by the chemical equation displayed besides here. All the other members of alkanes can be prepared by using the above general method. General property number 3 is that members of a given homologous series always show a gradual variation in their physical properties. And when we talk about physical properties in chemistry, we just mean the measurable physical parameters of a given compound, and may include solubility of a given compound, the color of a given compound, the density of a given compound, melting point of a given compound, and the boiling point of a given compound. To illustrate this, displayed besides here are the boiling points of the alkanes starting from hexane up to nonene. Notice that hexane is a 6-carbon alkane, and the last one in the table, which is nonene, is a 9-carbon alkane. So what can you conclude from the data given in that table there? Is that, well, there is an increase in boiling point as you move from hexane to nonene. The reason being increase in the carbon chain as you move from hexane to nonene. The last property of all homologous series is that members of a given homologous series have the same chemical properties. By basing on our example today, which is the homologous series of alkanes, is that all alkanes can undergo combustion in the presence of plenty of air to form carbon dioxide gas and water. The chemical equation displayed besides here shows the products formed from the combustion of methane. notice that you still get the same products, I mean carbon dioxide gas and water, if you, for example, performed the combustion of decane. With this, we therefore come to the end of our two basic concepts. I hope you learned something from the two basic concepts. Let me know by sending an email, by using the email in the description of this video, if there is any concept that is difficult for you in organic chemistry. Then I can always get back to you by means of video. Otherwise, for now, thank you very much for being part of this. Until next time, I remain yours, the chemistry teacher.